Hello, everyone. You are welcome to today's class. And in today's session, we are going to continue from where we left off. We are still on the topic trigonometry. Okay, in our previous meeting, we looked at angles of elevation and depression. One strong and typical application of what? Of trig. Okay, whereby we realize that, okay, questions will come in the word form in the problem, okay, a word problem form. You extract the diagram and proceed, okay, with this using your various, okay, trig concepts or techniques that we've learned so far. Okay, today we are going to continue, like I said. We'll look at one question on angle of depression where we left off. Okay, I know we have new students on board, and those, the old ones who couldn't really get that concept well, okay, this will be a fine opportunity to help shape what your understanding. So if you can help shape your understanding, you know you have a role to play. Where need be and you have to ask questions, please do ask questions. Okay, so before I walk you through or we go through the solution of the question that we have before us, please don't forget to subscribe, okay, to my YouTube channel, like and share. So quickly, let's look at the question before us. The angle of depression of a point on the ground from the top of a burden is 20.3 degrees. If the distance from the point to the foot of the burden is 4 meters, calculate the height of the burden correct to 1 decimal place. So remember, I've told you, anytime you read question and you see required approximation, okay, it is your duty to underline that required approximation. Sometimes it will come in bold, okay. If it comes in bold, then it means the question has directly told you to pay particular attention to that information that you have here. Okay, so you have, if it doesn't come in, but whether it come in bold or what have you, underline just to, okay, identify or protect your marks, if I should so put it. Now, after reading the question, underlining the salient parts, the first thing that you write is what? Solution. Okay, so now we've written solution. We have to go and picture the situation that we are dealing with in this question. We are told that an angle of depression of a point on the ground from the top of a burden. So it means I have a burden, and burden will be taken to be a vertical what burden. So assuming this is my burden, so my vertical burden, oops, my line is not too straight. Okay, but I think, okay, we can manage. Okay, so this is my vertical burden. Okay, and I'm on the top. Okay, so this is the top of the burden. Okay, obviously the bottom of the burden will be, okay, on the ground. All right. So we said the angle is taken from the top of the burden because we are told the angle of depression of a point on the ground from the top of the burden. So it means our reference point is the top of the burden. So let me use maybe T, okay, to represent the top of the burden. Okay, and B to represent maybe the bottom of the burden. Am I clear, my professors?
Yes, please.
Okay, all right. So once I am taking the angle from the top and I'm sighting an object what's below, it means obviously I'm looking at an angle of depression. Or once we are told that we are at the top, okay, and they've mentioned angle of depression, then it means you are going to sight an object down because your angle of a depression will always be a diagonal line below a certain horizontal line, which happens to be your original eye level. Okay, so in this case, where I am taking the measurement from, I always have to indicate a horizontal line. That is my original line of sight before I come and sight, okay, the object that I'm looking at now. So here we are told that on the ground, so the depression of a point on the ground from the top of a building. So let me assume this is the point on the ground. So this is the ground level as well. Okay, that's where the foot, okay, the bottom or the foot of the burden will be. So in this case, this is the ground level. So on this ground level, I have a point that I want to sight from the point T. So let me fix this point. This is the point that I want to sight. But if I can sight this point, I need to move a certain angle. Okay, this is the original line, a certain angle down before I can sight this. So I join these 2 points where I'm taking my measurement from the top of the tree to, okay, the point that I want to sight. I join these two, okay, with a line. Okay, so let me see. Oops. Okay, so this is what I have. Okay, so the angle here is what you are taking as what? Your angle of depression. So this angle is the angle 20.3 degrees. Point well made, my professors.
Yes, please.
Okay, so and we know from our last or our previous meeting that your angle of elevation depression must always be between a horizontal line and what? And a diagonal line. So if I take this to be an angle of depression, I have a horizontal line and a diagonal line. So indeed, if it's an angle of depression, then your diagonal line must always be below your horizontal line. If it is what? Elevation, then it should be above. Okay, Prof. Caroline.
Mr. Ekman, please, can you kindly go over it again?
Okay.
I want to get something clear.
From where?
Please, from the part where you drew the ground,
this one.
Yes, please.
Okay, so you have 2 points on the ground. Okay, this point that you want to sight is on the ground. The bottom or the foot of the burden will also be on the ground. Is that not it?
Yes, please.
So if these 2 points are on the ground, if I join, they are all at the same level, horizontal ground. Okay, so if you join, you get a horizontal line. Is that clear?
Yes, please.
Okay, so it means this is a horizontal line. So let me draw it as a continuous line. So this will now be, just for you to know, a continuous line. So this is what we have. And you know, I've told you that wherever you are taking your measurement from, in terms of the angle of elevation depression, where you are taking your measurement from, always draw a horizontal line. That will be your original line of sight. Before you either move down, okay, for depression angle, or you move out for elevation angle. Is that clear?
Yes, please.
Okay, so I was here, okay, my original line of sight from where I'm taking my measurement. Okay, because I'm talking about a depression, it means I need to move down before I can sight the object. So this angle here, that I move down to sight this object, that's what the question has given us, what? 20.3 degrees. Is it clear now?
Yes, please. Thank you.
Okay, so now I am going to label this point. Okay, so let me see, let me call this point A. It didn't come with any name. So I'm at liberty to use any name of my choice, any letter of my choice. However, like I told you, it's supposed to be a capital letter. So please take note. Okay, your burden is vertical. Your ground is horizontal. So when they meet, they will form an angle of 90. So always don't forget to indicate that. Let us know your angle 90 degrees, the right angle. And I told you in our last meeting that anytime you have, okay, an object, okay, you are sighting an object down, meaning you need to move through a certain angle to sight the object. If you are where the object is and you want to sight what the person initially where the person sighted the person here, okay, if you want to sight the person who is up, okay, you should also turn a certain angle. So if you are here and you are sighting the top of the burden, then you are supposed to turn a certain angle up, because this will be your original horizontal line. That's your line of sight. And you need to turn this angle up. And I told you that the angle that the person up here will turn down to locate the person down here, okay, will be the same angle that the person down here must turn up, okay, to sight the person up here. Is that clear, my professors? My professors, are you with me?
Yes, please.
Okay, so
yes,
I should know, with that a rocket scientist telling me that this will be 20.3 okay, degrees as well. So if I come and look at this right angle triangle, okay, obviously I know one angle, but there's one information that I'm left to, okay, bring to bear in terms of what the diagram that I have here. So let's see this information. What I've dealt with will be the first information. Okay, from here up to here. Now we are told if the distance from the point okay, to the foot of the burden. So this is the foot of the burden, okay, and this is the point. So the distance here, we are told, is 40 meters. Do you agree?
Yes, please.
Yes,
Okay,
please.
who wants me to come again?
Sir, please, me.
Okay, Crosby, from where?
Please, me.
Okay, from where?
Please, me.
From where?
Sir, please, from where you sight down.
Where I sight down.
Yes, please.
Okay, all right. Okay, so I think I said enough of this in our previous meeting. Okay, but no problem. Okay, if you don't get this, okay, whatever that we are going to do, you will struggle as well. Okay, and I don't want that to be your story. So I am going to go over. Okay, please listen and listen carefully. Usually it is the depression situation that students struggle. But I think I've done my best. But nonetheless, don't worry. We would still, okay, I will definitely have a way of explaining for you to come, everyone to be on board. Okay, so this is what we have. Those who understand, okay, up to this, continue. So that when you continue, you can check, okay, your answers with ours. Or along the line, if you wrote something that is what's wrong, you will be able to put us in check. Is that clear?
Yes,
Okay,
please.
so that it wouldn't be boring to you. Okay, so I'm starting all over again. We have, okay, this question I wanted, there will be an assignment on the depression angle. That's the more reason why I want to make sure that everyone understands this. Okay, so that in that assignment, you make all of us proud. Okay, so here we are told that we have, let me clear this. Okay, the angle of depression of a point on the ground. Okay, so from the top of the tree. So it means I'm at the top of a tree and I'm sighting an object down. Once an angle of depression, okay, is mentioned, it means your object that you are sighting is down. Okay, and you are up. Is that clear?
Yes, please.
Okay, so this is my burden, which is a vertical line. Okay, I cannot draw a burden, so you know I've told you, you represent that by a vertical line. Okay, then what do? I'm at the top of what's the burden, and I'm sighting an object down. So where I was initially, this is where I am, okay, my original position, okay, where I'm taking my angle. Okay, always there will be a horizontal line there. I've told you when you want to talk about elevation depression. That's your original line of sight. Then you want to now sight what? A. Okay, so join these 2 points. When you join, it will always be a diagonal line. So because this diagonal line, we are talking of angle of depression, this diagonal line must always be below your original horizontal line that you indicated here, which is what your original line of what sight. So this angle here, that's the angle that you have to move from your original line of sight, okay, to sight this object A. At the point A here is the angle that we are giving as what the angle of what depression, which the question says is 20.3 degrees. And you know, I've told you that the angle of elevation or depression must always be between a horizontal line and a diagonal line. So from the previous one, remember when I gave you the one that I said you should give me the picture, send the picture, only the diagram to me. Okay, some of you put the angle here. And I told you that that was flawed because I remember when I was introducing you to my introduction to elevation and depression, I told you your angle must be between a horizontal and a diagonal. So if you put the angle here, automatically you should know you are wrong because this angle that you've indicated is between a diagonal line and a vertical line, not a horizontal line. So you will get it wrong, but dishonorably, in the sense that, okay, you should have known, okay, that cannot possibly be your angle. Because I know if for nothing at all, my angle must be between a horizontal and a diagonal. So this is a horizontal, then my diagonal. So this rather becomes my angle. And I said that the angle of elevation, okay, let me say the angle that a person who is here must turn through to side the person who is down should be the same angle that the person who is here must turn through to side the person who is up. And I explained this concept from, okay, your usual properties of power line. Because this is horizontal and the ground level here, okay, this is also horizontal. Okay, these two are power lines. So therefore, this becomes what? A transversal. When this is a transversal, okay, you have properties of power lines angles coming out. So I told you that this angle here will be equal to this angle because they will form alternate angles. Is that clear?
Yes, please.
Okay. So when you are drawing, your original horizontal must be there, this angle must be there. Before your analysis will come and introduce what? This angle, so that you can use this triangle to do your analysis, okay, going forward. Point well made, Prof. Crosby, and okay, the rest.
Yes, please.
Okay, so I can move on. I think from here the work, okay, is done. Okay, so but I'm going to continue for the purposes of those who, okay, didn't join us, okay, the last time. So now what do? We are going to continue. Remember, okay, questions are numbered, our solution must be numbered as well. So this will be solution to question number 4. Oops, let me go back. Okay, so question number 4, let me indicate my question 4. Don't forget that. Okay, so now you are looking at a right angle triangle, one of the angles known and one of the sides known. And the question is asking us to calculate the height of the burden. So we are asked to find the length of TB. Do you agree?
Yes, please.
Okay, so if you like, you can represent this by h, small h for height. Okay, so in that case, I can say that, okay, I'm looking for the opposite, knowing the adjacent. So which trig ratio are we supposed to use, my professors?
Tan.
Tan. Okay, do you agree? Tan, opposite, then adjacent. So remember your SOCAT one. Tan, very, very good. So I'll come and write, but, okay, tan, my angle there, what is the angle? 20.3. Okay, degrees, okay, should be equal to opposite, which is h, over, if you didn't represent that by h, then you are supposed to use, okay, the length of TB or BT, as we've been doing. Is that clear? Okay, over 40. And I've told you, when you are forming your ratio, always ignore the unit because they will cancel in the long run. So I'm looking for h, so I can say that this implies that, okay, my h will be equal to, I have to multiply this by 40, multiply this by 40. So it will be 40, okay, tan, okay, 20.3 degrees. All correct, my professors?
Yes, please.
Okay, so I want to rely on you, okay, for the results, 40 tan 20.
$14.8.
Okay, so
14.8.
0.8, no. I won't take that as your answer now.
14.5.
796.
796. Okay, is that all?
Yes, please.
Okay, was it exact? It cannot be exact.
Sir, please, in the question, it says correct to 1 decimal place.
I know, right? Remember I told you, the first approximation should be how many DPs?
Step is 4.
4 DP before any required approximation or convenient approximation. Do you get it?
Yes, please.
Okay, so what you've given me, is it 4 DP?
No, please.
Okay, so let's do the right thing now that we know. So let's do the right thing.
7, 6, 4.
8, 4.
7,
9, 6, 4.
7, 9, 6, 4.
4.
I hope you check the next digits.
Yes.
Okay, so if you are right, then I'm also right. Okay, so in this case, height, we know that is length. So let's attach the units then. Okay, indicates, oops. Okay, so I'm praying this will not be the situation. Oops, okay, so let me quickly do this. Okay, usually, okay, my way is too sensitive now. My digital pen is too sensitive now. So let me work on it quickly. Then we come back. Let me see. Oops, it's still not, okay, showing, okay, what I want it to show. So give me some few seconds. Oops, okay, so let me stop recording and rectify this quickly. Forgive me. All right, so we said this will give us We don't forget our units. Oops. Okay, so we don't forget our units, which will be meters. Okay, then also you don't forget your approximation. Remember, we took this one to 4 dp. Anytime you approximate, never forget to indicate your approximation. So now we are going to draw our conclusion. In our conclusion, okay, we'll take our answer to 1 dp. So remember, 4 dp before convenient or required approximation. However, in this situation, it will be a required approximation. Is that clear?
Yes, sir.
Okay, so I'm going to write therefore, okay, what am I asked to find? The height of the burden. Okay, so burden height. Oops, my L didn't come. Okay, so burden height. Okay, will be equal to, so now it will be, let's go 14 point what? We said 1 dp, so it will be 0.8. Is that not it?
Yes.
Okay, then you put in, but don't forget your units. Then you come and put in bracket 1 dp. All correct.
Yes, please.
Okay, any questions, my professors? Are we all fine? Is everyone fine?
Yes,
Especially, okay, those who joined for the first time today. Have I been able to explain for you to understand? If you haven't done trig, okay, then you might struggle a little. But if you've done trig, okay, you should be able to relate. Okay, so can I move on?
Yes,
Yes,
please.
sir.
Okay, great. All right. So if that's the case, then I'm moving on. Okay, remember this will be your class assignment. That is if time allows. Otherwise, it will be your homework. Okay, so let's move on to another concept. Okay, the same elevation and depression. Okay, however, if you look at the examples that we've handled so far, okay, the elevation, depression taken from only 1 point. So we had only one angle of elevation or depression. However, if you look at this question that we have before us, how many angles do you see?
2.
2 angles. Okay, so it means this is going to be a little different from what we've done so far. Okay, but the technique, the idea, the concept, not different. It's the same thing, only that here it will involve a little more work, sort of. So this is what we are going to do. Okay, so let me see. At this point, I want to pause. I'm going to give you a simple exercise like I did the last time. Okay, I'm going to pause, read the question that we have there, try to give me the picture. Try to picture the situation yourself. Okay, and send your diagram, only your diagram. Okay, what you are able to visualize, put it into a diagram form. Okay, and send it to me on the class page. Please take note, on the class page, not on what, on the your private what page. Please take note. All right, so I'm going to pause and give you that opportunity to do so. And that will help me to carry out my explanation. Okay, from your submissions, I will need that to carry out my explanation. All right, so having gone through the diagrams that you sent to me, interesting diagrams, okay, of course, please let's see how best we are supposed to deal with it. Okay, if you had it right, you give yourself thumbs up or you pat yourself at the back. Okay, if you didn't get everything so right, okay, yes, it's allowed. You make mistake, you learn from your mistakes. So after the explanation, you know, okay, how to deal with it going forward. Okay, so we are told 2 points, okay, P and Q, 15 meters apart. Okay, so if nothing at all, we know the distance between P and Q. All correct. All correct, my professors.
Yes, please.
And these 2 points, they are in line with the tree. Okay, the angles of elevation of the top of the tree are 22 degrees and 32 degrees respectively. So at 1 point, so here, because we are talking about respectively, it means you are at P and you want to sight the top of the tree, you need to move an angle of 22 degrees. If you are at Q and you want to sight the top of the tree, you need to move an angle of 32 degrees. All correct.
Yes, please.
So here, because we are talking of angle of what, or angles of elevation, okay, we know that these 2 points P and Q should be below the top of what, of the tree, so that you can elevate before seeing the top of the tree. So this is the situation. Okay, at the normal circumstance, okay, there would be 2 or 3 possible solutions or situations, but I will let you know that this is the particular situation anytime you are dealing with this question. First of all, take note, if you are not told that the 2 points that you have there, they are the opposite side of the tree, it means you are supposed to have these 2 points on the same side of the tree. Points well made, or I should come again?
Please come again.
Please come
Okay.
again.
So here, you know that I have 2 points. Let me, okay, so before I even start drawing, get this, okay, like I was saying. Okay, I'm saying that you are not told, you are, okay, you have a tree. So let me fix my tree. Okay, so let me fix my tree. Okay, I'll come and draw it well. Let's get a rough picture here. Then later I will come in. So I have my tree. Okay, so this is my tree. It's not looking too horizontal. It's just a rough one. Okay, so now what do? We said we have 2 points, P and Q. Okay, but we are not told whether P and Q are on the opposite side of what, of the tree, or on the same side. And I'm saying that if the question is silent on opposite, then you must assume, or you take the 2 points to be on the same side of the tree. All correct? So if they were on the opposite side, then it means maybe P could be here and Q could be here, or vice versa. Point well made.
Yes, please.
Okay, but here we are not told. Anytime the question is silent on, okay, opposites, you should know that, like I said, they are on the same side. So if that's the case, then let me go and clear that, then put them on the same side. Then another vital information will come in. So here, oops, okay, I didn't want the tree to go, but it has vanished. No problem, I will deal with it. So I have my tree. Okay, one possible situation. Another possible situation, let me draw it here. So I have 2 points, okay, P and Q. So this is P, this is Q. Okay, on the same side. It could be here or it could be here. I have indicated the 2 points here. Somebody can do PQ here as well. I hope you get my point.
Yes, please.
Yes.
Okay, or it could be the same. This time around, Q could be here. Okay, or P could be, and P could be here. Okay, let me bring it down a little. This is Q, this is P. Okay, still they are all, okay, on the same side. Is that not it? Only that their positions, okay, changed. Correct, all correct, my professors.
Yes, please.
Yes,
Okay,
please.
so if you know that now, it will not be opposite, and it will be any of these 2. This is what we are going to do. So now, okay, if I'm at P, and I want to size the top of the tree, I need to move through a certain angle. So meaning if I join P and the top of the tree, the angle between, okay, we are told that when we are at P, what is the angle? And you want to size the top, what is the angle? 22, is that not it? So it means this angle will be 22. Is that clear?
Yes, please.
Okay, if you are here at Q and you want to size the top of the tree, it means, okay, if I join P and, sorry, the top of the tree and Q, the angle there is what I will take as my angle of elevation, and that is 32 degrees. Is that clear?
Yes, sir.
Yes, please.
Okay, the same thing here. If I'm at Q and I want to size the top of the tree, the angle here must be 32. I hope you are with me. And if we're at P, this time around, the angle here will be 22 degrees. All correct?
Yes, please.
Okay, do you agree that the 2 diagrams are not the same?
Yes.
Please, do you all agree that they are not the same? Okay, yes. You know that as for the distance, I will come. As for the distance, you know. Okay, that is given. I've ignored the distance now. I'm now interested in the angles. Okay, now, okay, these 2 situation diagrams that we have here, we said this will be the possible 2, but always there will be 1. So which one do you settle on? Okay, so I want you to let me know if you settle on the diagram 1. Tell me why you should settle on diagram 1. And if you settle on diagram 2, tell me why. You put up your hand, okay, then you answer. I know at least someone will know. Okay, Prof. Genius. So, Prof. Genius, diagram 1. Okay, why?
Okay, sir, please. 22 degrees is less than 32 degrees. So meaning that it will be possible for a 32-degree angle to fit inside a 32-degree angle.
Okay, that's your answer. Okay, interesting. Okay, that's your answer. So you are looking at the angle fitting in between. No, you should know that this line that you have here is not also here. For you to say that this one should be inside, what have you? You get it? Okay, but that's just your answer. I will let you know more, okay, the more reason, okay, or the better reason why it shouldn't be so. Okay, but on the face of it, that's what I've said. Okay, so any other, maybe 2 more. Okay, Prof. Nana Kwame.
Because according to the question, the angle of elevation of the top of the tree are 22 degrees and 32 degrees respectively. So the 22 degrees should come before the 32 degrees.
Okay, so that's what you have there. So you also agree that diagram 1?
Yes.
Okay, good. Any different opinion? If you are still going for diagram 1, then don't put up your hand. I want maybe diagram 2. Okay, and okay, Prof. Augustine.
Please, I go for diagram 2.
Okay, why?
Because the angle at which the keel is elevating upwards looks bigger than the angle at which P is.
Should look bigger.
Like it's looking larger than the P.
Why?
Say please, from the ground to the line, it looks.
You are saying that it's looking bigger because when you join, it looks bigger. You are not drawing to scale, but you are still saying that it will look bigger. Isn't the looks?
Yes, please.
Okay, you are using the looks. So maybe you will be lucky, but your reason, okay, it's not, I'm not going to take it's not the looks. Okay, there's a vital information, okay, that all other things being equal. Okay, Prof. Selikem, maybe this will be the last. Then you go, Selikem.
So please, I'll go for diagram 2
Why?
because I think it correctly shows both points, the P and Q. And also, I think the angle of elevation close to the base is supposed to be large. And since 32 is larger than 22 degrees, it has to be closer to the base of the tree.
The base of the tree. Okay. I think I get your point, but I'm going to put it in a way that everyone can relate. Okay, so this is simple. Take note, okay, of this vital information that I'm going to throw at you. The closer you are to your object, the bigger your angle of elevation. Should I say it again?
Yes, sir.
Okay, so I'm repeating. The closer you are to your object, okay, the bigger the angle of elevation. If you like, okay, on your own, you can, okay, try. Usually, I'll pick students out, then we'll do this, demonstrate this together. Unfortunately, I can't do, but I can still let you picture the situation. So, assuming maybe you are, okay, you are far away from a burden. You can see that if you are far away from the burden, you can easily see the roof of the burden, true or false?
True.
You agree. However, as you move closer to the burden, before you can see the roof, you have to be moving your head, okay, up, higher. I hope you get my point.
Yes, please.
So once you are moving your head up higher, it means the closer you are, the bigger your angle of elevation because you are moving more angle up. All correct now. Is my point well made here?
Yes, please.
Okay, so this shows that with this information, this shows that the Q must be here and the P must be here. Because you can see that, okay, you know for a fact that the closer you are to your object, this is your object, the tree, where you want to side the top of the tree. The closer you are, the bigger your angle of it. So if you draw this, okay, automatically you are wrong. Point well made now. So now for a fact, the closer you are, okay, to your object, the bigger your angle of elevation. All correct. So can we proceed? My professors, are you there? Can you proceed? Or if you want me to come again, remember, I'm here because of you. We've not gone far.
Please come again.
Okay, so I said the right option will be this. Okay, remember, okay, in these two angles that you have there, the angle at Q is the biggest angle. And we know for a fact now that, okay, the closer you are to your object, this is my object, my what do you call it, the tree that I'm sighting its top. Okay, so the closer I am to, okay, the object that I want to sight, okay, because if I look at this, okay, Q and P, this one is closer than P. I hope you can see that. Or better still, if you take the tree as what your object, okay, Q is closer towards the tree than P. So the closer you are to your object, okay, the bigger your angle of elevation. However, if you look at this, P is closer, okay, to the tree than Q. As you can see that P is having a smaller angle. So that is not depicting the true real life situation. Because closer, bigger. So it means rather the Q must be here and the P must be here. So if the Q is here, then the angle here must be 32. If P is here, the angle here must be 22. So this then becomes what the situation that we are looking at. Is it clear now?
Yes.
Okay, very good. So now that we know this is the picture. Okay, first of all, we know that I have a tree. So I'm going to draw my tree. A vertical line. Okay, then I have 2 points on the same side. It was silent on opposite, so I know that the 2 points are on the same side. So let me pick my point here, 1 point here, 1 point here. Okay, but the point will be P and Q. So I don't know which one to put here, whether P will be here or Q will be here or, okay, vice versa. But now with this extra information, okay, we know that the bigger angle, okay, the points that, okay, will give us the bigger angle of elevation must be closer. And that point is what? Q. So it means Q must be here and P must be here. All correct. Okay, so I'm explaining again. So now from Q, I want to sight the top of the tree. So this is the top of the tree. So I join, okay, the top of the tree and what? And Q. Okay, and that gives me the angle, okay, 32 there. Oops. That's the angle of elevation, 32 degrees. And remember, you cannot use your free hand. Okay, you cannot draw in ink as well. So let me indicate my 90. And from the point P, if I want to sight the top of the tree, okay, I am supposed to move a certain angle. So if I join, the angle here is the angle that I'm supposed to take as 22 degrees. All correct now, but I'm told that the distance between P and Q is 15 meters. So I know this distance is 15 meters. Afa?
Yes, please.
Okay. I hope I've not left anyone behind and you've not left yourself behind too. Okay, so if that is the situation, then we should be more than good to go. Okay, so now this is what we are going to do. Okay, from here, a little bit of analysis. Okay, those of you who were with us the last vacation, okay, the lesson 4 video that I sent to you, okay, you have a certain situation and how to deal with it. And we are going to apply, okay, that same concept. Those who couldn't join, okay, remember I sent a video for you to watch before joining for a smooth, okay, lesson today. So if you didn't, okay, later you can go and watch it. Okay, that's if you are not able to relate well with what I'm going to do from here. Okay, you know math is a bird app. So this is it. Okay, now how many right angle triangles can we extract from this figure? How many?
Two.
Two. Okay, so let me clear that. Okay, the first one wasn't looking straight at all. I think this one is better. Okay, you will be using straight edge. I could have picked that, but If I move on, then that will be okay. So 2. Okay, so I am going to break it down. Remember, I've told you anytime you have composite figures like this, break it down. Okay, so let me label my vertices anyway. They didn't come with any name apart from the P and Q, so I'm at liberty to use. Okay, so this is the top. Let me use T. I could have used A and B, provided I haven't used that. Okay, and this is the bottom. Let me use B. Okay, all right. So, and I was asked to find the height. So let me represent the height by H, as I did previously. Or you can still use TB. Point well made, my professors.
Yes, please.
Okay, so now this is what we are going to do. Let's break down the diagram that we have there into the 2 possible right angle triangles, like I said. So break it down. Okay, so I have my first right angle triangle. Okay, then my second right angle triangle. Okay, I'm drawing it very small. Okay, it's just a rough work. Okay, so right angle triangle. Okay, the bigger one is, let me indicate the bigger one first. Doesn't really matter which one you indicate first. Okay, all right. So T, B, okay, P. Okay, then the smaller one is what? T, B, Q. I hope you are following. My professors, are you with me?
Yes, sir.
Okay, so the bigger one, I know this angle to be 22. Okay, degrees. All right. Okay. Do I know the distance from B to P? I don't know. Is that not it?
Yes, sir.
Okay. So let me call this distance, okay, X. So if I call this distance X, okay, then it means I know the distance from B to P. That will be 15 plus X. Do you agree?
Yes, sir.
My professors, is everyone following?
Yes, sir.
Okay, very good. Now, okay, any other, I know that this is what? H. Okay, again, I know this is H. Do I know BQ? Yes, I represented that by X. Is that not it? My professor, should I come again or you are all with me?
Yes, please.
I should come again.
Yes.
Yes, please.
Okay, that's okay. All right. Okay, so this is it. Okay, you know that the 2 possible right angle triangle that we can extract from this would be this small right angle triangle and the bigger right angle triangle. So that's what I have here. Only that I had the bigger one drawn first. Okay, followed by the smaller one. I hope you get it. So I didn't indicate my 32. So let me indicate the 32 here. So I have a missing angle here, 32 degrees. All correct. So it means this figure that I have here is what I've extracted here. The bigger figure that is what I've extracted here. Okay, and I label this side as H. Okay, label the distance here as X. Okay, this one was given in the question, and these angles also came from the question. So we know if you take the bigger triangle, right angle triangle, to be more specific, you will see that the distance BP will be made, okay, by BQ plus QP. So that would be X plus 15, okay, or 15 plus X. Is that clear? That's your distance BP. Okay, and your distance BQ. Remember, if you take this, the distance BQ is what you have represented by X. So this becomes X. Is it correct now? Are we all fine now?
Yes, sir.
Okay, so very good. So now from here, remember, okay, in our previous lesson, I told you, even in the lesson 4, the last vacation classes, and okay, this time around, the vacation class that we are having. In our previous lessons, remember I told you, once you break the diagram down, okay, you ask yourself whether, okay, you have a common side or a common angle. Do you remember? Okay, so between these 2 triangles, do we have a common side?
Yes, sir.
We do have a common side. Do you agree? We have a common side, TB. TB.
Say the H.
Yes, which is the H. Okay, so once you have a common side, remember the previous one that we did. We said if you have a common angle, you form an equation based on the common angle. if you have what? A common side. Likewise, you should form an equation based on the common side. All correct?
Yes, sir.
Okay, so that's exactly what we are going to do here. And that concept I talked about that, more in that lesson 4 video. So we are going to still make use of that here. So I'll write from, once you have more than 2 diagrams, let us know the one that you are going to work on. So from, instead of indicating right angle triangle, you can still do triangle. It's allowed. Okay, only that to be more specific, I will use the right angle triangle. So from which triangle? Let me go for this one, the first one that I have here. So I'm going to get, that triangle, which is triangle TBP. Okay, if I have space, I can continue and come and write, comma, then continue. So I'm going to continue. So from that triangle, you can see that opposite, adjacent, an angle. So which trig ratio should come to mind? Tan. So I'm going to, if I write tan, please listen carefully, don't write. Let's get a little bit of algebra here, understanding first. Tan 22 degrees will be equal to the opposite, which is h, over 15 plus x, or x plus 15. Is that clear?
Yes.
Okay, so remember I told you we are forming an equation based on the height. Okay, the common side. So it means you have to make the common side a subject. So in this case, I'm not done before I label my equation. All right, this implies that if I make a the subject, I have to multiply this side by 15 plus h, this side by 15 plus h. So I'm going to, because it's a binomial, I will put it in brackets. So I'm going to get 15 plus, did I say plus h plus x? Okay, if that's what I said, forgive me. Plus x tan, 22 degrees should be equal to h. Do you agree? Or h should be equal to that. My professors, are you with me?
Yes, please.
Okay, so I will label, I've made h the surface, so I will label this one as equation 1. Now let's go and take the second triangle too. So let's do it together. Maximum attention. Okay, so from, triangle, right angle triangle, TBQ. Okay, what do we have again? Okay, opposite, adjacent. So which trig ratio? Tan, is that not it? So it will be tan.
Yes.
What angle this time round?
Tan 32.
32 degrees. Okay, should be equal to opposite, which is what? H, over the adjacent, which is what? X. All correct.
Yes, please.
Okay, so can I also say that this implies that, my x, tan 32 degrees, should be equal to h, or h should be equal to that. So I will label this as equation 2. All correct?
Yes.
Okay, so you are saying that h is equal to this, and the same h is equal to that. So just like we did for the other one, where we have tan theta is equal to this, tan theta is equal to this, then we equated. Okay, here we are going to have equation 1, should be equal to equation 2. Okay, so on that note, my equation 1, which is this side, should be equal to equation 2 this side. Is that clear? Do I have to come again, or you are all fine?
Please come again.
Okay, I should come again from where? Okay, Prof. Portia, did you watch the video that I asked you to watch before joining?
No.
I know you said no. So that's it. When you do this, you just draw us back, or you draw yourself back. I know math is a prerequisite. There's something that we've done before. So I don't have to spend time going back. You have the videos. I know. That's why I always say you have your role to play. I equally have my role to play. So if you fail to do yours well, you tend to indirectly frustrate me. If I don't do mine well, it will have the same effect. You will be frustrated. If you come to class and I don't teach well, wouldn't you be frustrated?
Yes, please.
That's it. Okay, so if my aspect, if I don't do it well, it will have an effect on you. your part, if you don't do it well, equally have the effect on me. So that's why I said we are in this business together. Okay, so please let's all play our roles well, and we'll always have a smooth sail. So I don't want to have this situation. We've dealt with it in the lesson 4. If you like, go and check. So that's the more reason why I started with the diagrams first. If you know how to deal with the analysis based on the diagrams, okay, then if you're able to extract the diagram, when the diagram is not given and you are able to extract, now you know how to deal with the diagram. So you go and work with the diagram. So I have a way of teaching. Okay, we know how to analyze diagrams when it comes directly. Here, the diagram didn't come directly. We have to extract the diagram. Now, we've taken the question to our comfort zone because we know the diagram. Then we go. However, don't worry, I will still, continue. We'll do maybe 1 or 2 more. If you are not able to get it there, you go back and watch that video. It will be very useful. Okay, thanks for your understanding. Okay, anytime I send you videos, I plead, I humbly do so. Please try and watch it because I know you would need it for a smooth sail. That's why I sent it to you. Okay, all right. So now this is what we have, equation 1. Okay, so thanks for your understanding, Portia. Okay, and I know going forward you do the right thing. All right, okay, so equation 1 is equal to equation 2. So this, okay, my 15 plus x, okay, tan 22 degrees should be equal to the same h is equal to this, so it should be equal to x, okay, tan 32 degrees. All correct?
Yes, please.
Okay, so all right, so now what are we looking for? If you are able to find x, then we know, okay, we can get the distance. The question is asking us to find the distance of the point P from the tree. So the distance of the point P from the tree will be the entire distance here. Is that not it? Okay, you should have done this analysis before. Okay, but don't worry. Okay, because I know you've encountered this situation before in the lesson 4. That's the more reason why we didn't analyze before. So before I can get the distance here, I have to find my x. And that's the more reason why I'm forming an equation in x, and that will help me find x, and I will therefore know the length here. I will add it to 15, then I will know the length, okay, for the A that I'm looking for. Then we go and find the h. Is that clear?
Yes, sir.
Okay, so now this is what we do. We are going to expand this. So this will come and multiply tan 22 degrees. Never use your calculators here. Otherwise, you do multiple approximation, which will move you away from the accurate, okay, or precise answer. So keep your tan, whatever. At a point where you can use your calculator, I will tell you. So this will give you 15 tan 22 degrees. We are expanding. It will be this 1 times this. So that will give us, this implies that. Okay, I hope you are following my professors. So we get 15 tan, hey, let's go, help me, tan 22 degrees. Okay, then plus x tan 22, do you agree?
Yes, please.
That should be equal to, okay, x tan 32 degrees, all correct. Okay, so what are we looking for? We are looking for x, Abi. We are looking for x, right?
Yes, sir.
Okay, so it means we have to collect all the terms in x on one side. Okay, so it means because you have x, okay, term on each side, you have to move. But always one movement will be ideal. So if I move this one to this side, okay, remember I told you, how do you make the determination that this movement is ideal? When you move, okay, and you have the least number of negative terms, okay, on both sides, then it means you've done the ideal movement. So if I move, I'm doing that mentally. If I move this one to this side, I'm going to have this to be negative here. So throughout what I have here, it will be this positive number, okay, or term is equal to this positive term minus this positive. So only one, okay, negative term, which is located on this side. However, if I bring this one here, I have to take this one to this side. So if I bring this one here, you should know that this will give you a negative term. So there will be one negative term here. And if I move this one here, okay, it will become negative. So there will be another negative term here. So one negative term to each side, making it all, in all, two negative terms. So it means that movement will not be ideal. It will be better I move this one to this side so that I have only one negative term to contend with. Is that clear? My professors, are you with me?
Yes, please.
Okay, so now I am going to move this one to this side, but I will still write it first. That's not to say I'm moving. So I will have x. Remember, so if I'm moving, I will get x. I will maintain this term here, x tan, okay, 32 degrees. Okay, then minus, this one will become negative. So minus tan, okay, x tan 22 degrees. Okay, that will be equal to, I move this one to this side. So this one will be positive here. Okay, so that will give me 15, okay, tan 22 degrees. All correct. Okay, my professors, are you okay with that step?
Yes, sir.
Is everyone fine?
Yes,
Okay,
please.
so now you know you are making x a subject. So you come and factor out x in, okay, these two terms that you have there. So x will come out, okay, here. So that will be x. Then in brackets, tan, okay, 32 degrees. Then minus, if x comes out, you'll be left with tan, okay, 22 degrees. And you close it, and this should be equal to what? Your 15, okay, tan, okay, 22 degrees. All correct. So your next step will be you write this, okay, you are going to divide through by tan 32 degrees minus tan 22 degrees. So if you divide through, this will go. So you get s is equal to the whole of this over, okay, the whole of what you have here. Is that clear? So I'm going to write that one on my next step, okay, or which will be my next page. Are you with me? Oh, is it the next page or are we still on? Okay, so it means please give me some few seconds. Let me duplicate, okay, that slide because the solution didn't go there. Okay, all right. So give me some few seconds. Okay. So from where we are coming from, remember this is where we are coming from. Okay, so we said x will be equal to, okay, you write it and you divide each side by, okay, what you have here. So that's going to give us x is equal to, if you go back, you can see that we'll get 15 tan 22 degrees over tan 32 degrees minus tan 22 degrees. So we are going to write that. So 15 tan, okay, 32 degrees. Am I right? It's tan 22. Okay, so tan 22 degrees all over, okay, tan 22 degrees. Okay, let me see whether it's tan 22 minus tan. It's rather tan 32. Other than that, it will give us negative. Oops, what am I doing? Let me see. Okay, so tan 32 degrees, okay, minus tan 22 degrees. Okay, because they are looking alike, let me correct that quickly. Okay, I hope you are following my professors.
Yes,
sir.
Okay, so at this point, you can use your calculator to find this value. Okay, and you approximate, okay, once. Okay, so I'm waiting, okay, for that approximation. So that will be equal to 15 times 22 degrees over. So let's go. It's calculator work, so you shouldn't waste time. I'm relying on you for your calculator values.
27.
27, exactly?
No, 27.4420.
27.4421.
1.
Then it means you didn't
21.
consider the next digit. Consider, please. That's why we've taught you how to approximate. Okay, so 21. Okay, and we are dealing with x is a distance. So let's see if you know its unit. The unit is what? It's meters. So it will be meters. Don't forget. Then you don't forget to indicate your approximation. We have approximated this one to 4 dp. All correct. Okay, so what we are doing, okay, is for the A. So at a point, I've told you every question number that you have should be in your solution number as well. So maybe you could have started here, A. Okay, label this as A. Put our A here, meaning I'm solving for the A answer. So you can put A here, or if you don't put A here, when you are going to answer for, the distance of P from what, you can put A there. So I can also come and put A there. That is, if I didn't put my A can come here. And I can come and say, therefore, what was I asked to find? The distance of P from the tree. So distance of, okay, P from, okay, the tree. Okay, will be equal to, remember, you said the distance will be X, okay, plus what? 15. So that will give us what? X, we have found that is 27.4421, okay, plus, okay, 15. Okay, so that will give us, I'm waiting. I hope you are with me that distance will be, remember, we were able to recognize this distance as what? X plus what? That's the distance of P from the tree. Okay, this will be the distance we are looking for. So it will be S plus this or this plus X. So now let's go.
42.4421.
42.44, okay, 21. Don't forget your unit, okay, your final unit, and that will be what? Meters. Okay, you don't indicate 4dp because you already indicated that there's a 4dp approximation, and your answer is also exact 4dp. Don't, okay. Here, there is no required approximation. Was there any required approximation? No. So it means we leave our answer in the 4dp. Afa?
Yes, please.
Okay, so that will be it for only the A. Now let's go and look at the B. So B, okay, what are we looking for? The height of the tree, is that not it?
Yes.
So I can write therefore, okay, tree height, or the height of the tree. You represented that by H. And you can see that we said H is equal to, let's go to what we were doing. We said H is equal to this, is that not it? My professors, are you with me? H is equal to this, and the same H is equal to this. So between these two H, which one do you think is pretty for us to go for?
Equation 2.
The equation 2. So use this H. Okay, if you use it, I'll ask you to do this, you end up getting the same result, only that you do a little more work here. So I will go for this, because the value here should be the same as this. So if I do this, the result that I will get to be the same, but this will be less stressful. So now I go, it will be X times 32 degrees. So let's go and do that. Once I know X, I know my, okay, my H. So it will be X, okay, tan, okay, 32 degrees. So that will be equal to, what is your X? Use the 4dp, which is 27, okay, 0.4421, okay, tan, okay, 32 degrees. So I'm waiting on my degrees is looking like, okay, a value 320. So let me go and correct that. Matt, whatever that you write, possibly can change your meaning. So let me indicate it well. Okay, so I'm waiting for your final answer.
17.1477.
Come again, 17.
0.1477.
1477. Okay, and you approximated, is that not it? Okay, so it will be meters. Don't forget, then you indicate your approximation for dp. All right, so now, okay, remember, therefore, it's already here. So you've done your conclusion. So let's go and see whether, okay, the common sense that we were trying to make it out from the diagram. Okay, so let's look at the X value. So let's see. Oops, forgive me. So let's look at the diagram. Okay, so obviously, okay, you can see that, okay, that the whole of this distance, okay, would be longer than this distance. Okay, therefore, the angle here, okay, because remember before we got this to be, was it the one which is for 14 point something, forgive me. Okay, so 27, sorry, forgive me. So X, that was 27. Okay, so this is 27, and the other one we had this plus the 27 and the decimals. So this is longer than, okay, this side, and therefore the angle here should be smaller than the angle here. Afa?
Yes, please.
Okay, so that will be it for question 6. Any questions before we move on to our next question? Looking at the time, I don't think we'll be able to do the class exercise. It will be given as a take-home assignment, no issue. Okay, so let's go and look at what question 7. Okay, so question 7, this is what we have. Okay, so this one, we can see 2 points A and C, opposite sides. So you underline opposite. So this one, you know clearly where they are. No ambiguity. Is that not? Okay, so it means if I have my vertical pole, let me move straight to the point. So I have a vertical pole. Okay, and I have 2 points, okay, opposite sides. So maybe, okay, 1 point here, 1 point here, opposite. All correct?
Yes.
Okay, so opposites of a vertical pole are on the same level as the foot of the pole. So if this is the foot of the pole, okay, so the same level, so it means, okay, on the same horizontal, okay, level. So this is what we have. So the foot of the pole, it didn't come, let me see whether it came with names. The foot of the pole B, is that not? So it means here I'm compelled to call this B. All correct?
Yes, please.
Okay, so take the if names are given, you are not at liberty to indicate any name. Go strictly by the names. Okay, so the angles of elevation of the top of the pole D. So the top of the pole, what is the name? D, is that not it?
Yes, please.
Okay, now let me assume this is my A. Okay, you know, you said these 2 points, A and C. Okay, so this is C. This is what we have here. Okay, A and C is a special name when it comes to a particular school. Okay, they know immediately you say A and C, it rings a bell. All right, they know themselves. Okay, so this is what we have. Okay, so at this point, remember, we are told, okay, so the first part down to the second part, okay, are 30 degrees and 48 degrees respectively. So you know the angle, okay, of elevation at A, okay, is what 30, and that at C is what 48. So it means at A, if I want to sight the top of the tree, remember we said all that we are having here are on top of the tree, the angles of elevation here relative to the top of the tree. So at A, okay, if I connect A and the top of the tree, okay, the angle that I need to get here will be 30 degrees. Do you agree?
Yes.
My professors, are you with me?
Yes.
And at C, if I join C and the top of the tree, this angle here, okay, must be what? 48 degrees. All correct, my professors.
Yes.
And obviously, it's an angle of elevation because, okay, you are at C and you want to sight the top of the tree. So your diagonal must come, this is your original side, because your point is to this side of the C. So it means your original sight, line of sight will be here, okay, which will be your horizontal line. Okay, then now you move through a certain angle before you can sight C. Same explains that of this situation. A, the point that's where you want to sight is on this side. So the original line of sight will be here, horizontal line. Then you need to move a certain angle up before you can see what's the D. And that will give us the angle 30 degrees that you have there. Any extra information that we are, so let's see. If the distance between A and C is 50, so I know this distance from here to here. Let me calm down a little. Okay, so this is 50 meters. Do you agree?
Yes.
Okay, remember I told you, don't forget to indicate your 90. One will be okay. Once this one is indicated, because this is a straight line, you should know that this is also 90. So you don't have to necessarily do both. Okay, so now this is what we are going to do, just some basic analysis. Okay, so how many right angle triangles can we get from what we have there? Maximum right angle triangles.
2.
2. It will be this one and this one. The bigger one that you have there is not a right angle triangle. So it will be this and that. Do you all agree? Okay, so if you agree, then we go and break it down. Remember the rule. Okay, break it down. Your 2 okay, right angles that you can extract from that. Okay, go and extract and use it to do your analysis. Usually better. If you can use the original one to do your analysis too, without, that is the matured way. You do that. Okay, it's allowed. I'm saying that indirectly it's allowed. So my, okay, first right angle triangle here, I've changed the orientation. This one is flipped to this side. If you want to draw it to follow the same orientation, it's allowed. That's as I explained in the lesson 4 video. Okay, so now what do we have? We have D here. Okay, we have A here. Sorry, B is where you have your 90. Then A will be here. Take note. Okay, so fix your 90 first. My 90 is at B. Okay, then this one is the same orientation. So no struggle. I guess my point is well made.
Yes.
Okay, so now let's indicate angles that we know, then size that we know. We know the angle at A to be 30, so 30 degrees. Okay, the angle at what? At C to be 48, so 48 degrees. Afa?
Yes, sir.
Okay, do we know the length of AB? Hello, do you know the length of AB?
It will be 25.
No. We didn't say once they are not moving the same distance, once these two angles are not the same, you can't say that this line is bisected, you know, from, okay, plane geometry 1, triangles. This cannot be a line of symmetry. You get the point. So immediately you do that, it's a wrong assumption. If this angle is equal to this angle, then we can say that, okay, indirectly it's possible this side will be equal to this side. All correct. Okay, so now what do we have? So let's go. Okay, so I don't know, so I'm calling this X. Is that clear? So this will be X. If this is X, what do you think will be the length of this side?
15 X.
It will be, do you agree to be 50 minus X? Do you all agree? Or I should come again?
Come again.
Okay, so if the entire length of this, if this plus this, so let me call maybe this one Y. Okay, so if X plus Y is equal to what? 50, then Y will be equal to 50 minus X. Do you get it now?
Yes, sir.
Okay, so we now agree that the whole of this will be 50 minus X. All correct?
Yes, please.
Okay. All right. So again, I'm going to put that one here. So 50, okay, minus X. Afa. Please, my time is almost up. Okay, so let's see if you can do the analysis up to a point. Okay, so now, okay, let's study the two diagrams that we have here. The two simple diagrams that we extracted from this. Let's check whether, okay, the two right angles triangle, they have a common angle. They don't have a common angle. Can you see that? So the equation that we are going to form should not be about the angle. Do they have a common side?
Yes.
They do have a common side. That's the height of the pole. So let's call this H. Okay, so maybe this one H. Okay, this will also be H if you like. You can choose not to put it here, but the one that you are going to use to do your analysis, you go. Okay, so once you have a common side, again, our equation will be based on common angle or common side. Now, professors, which one do we go for? Common side. Okay, so you come and take your first triangle. So from, okay, your first right angle triangle, I'm going back to, okay, that is right angle triangle D, B, A. Okay, comma. Okay, so we opposite adjacent, which trig ratio? Again, tan, is that not it?
Yes, please.
So tan, which angle? 30 degrees. Should be equal to the opposite, which is H, over, okay, our adjacent, which is X. So I'm going to make H the subject. So this time around, I can say that H will be equal to S tan 30. Do you agree? Professors, are you with me?
Yes, please.
Yes.
Okay, so that becomes my equation 1. Okay, then from my second right angle triangle, okay, that is D, B, C. comma, again, opposite adjacent, so tan. So tan, my angle there is 48 degrees, should be equal to the opposite, which is h, over the adjacent, which is 50 minus x. All correct. Okay, so if you come and make h the subject here too, we are going to get, this implies that h will be equal to, you are going to multiply this by that. And I've told you whatever that you are going to multiply by the trig, function that we have here should be its coefficient. But because it's a binomial, we put it in brackets. Failure to do that will be costly, to change the meaning. So it will be my binomial 50 minus x, the whole of that times what? My tan 48. Degrees. All correct. So I can comfortably call this equation 2. Professors, I hope you are with me.
Yes, please.
Okay, so I know that equation 1 should be equal to equation 2. Comma. So this means that, my x tan 30 here should be equal to 50 minus x, the whole of that tan 48. So I'll write this as x, tan 30 degrees, will be equal to what? 50 minus x, in brackets, tan 48 degrees. Afa. Hello, Afa.
Yes, please.
Okay, so here we are finding the height of the tree. But before I can find the height of the tree, I need to find my x, because the height h is in terms of x. So that's the more reason why we are looking for. And here, we didn't number our solution too, so please take note. Question number 7. I guess the previous one we did. So now what do? We are going to expand this, then collect the terms in x. So this implies that, your x tan, 30 degrees, should be equal to, when you expand, we are going to get 50 times this. So that will give us what? 50, tan 48 degrees. Then minus x tan 48. Do you agree? My professors, are you with me?
Yes.
So now, just like we did in the previous one example, we collect the terms in x. So if I move this one to this side, I'm going to get this term to be negative. It will come and meet a negative term here. So I'll have 2 negative terms here. Then I have to move this one to the side, which will be negative. So I'll get 3 negative terms. However, if I bring this one here, all the terms here will be positive. This will be made here as positive, so no negative term. So it means ideally I have to move this one to the side. So I'm going to do same, having inspected and checked which side, movements will be ideal. So 30 degrees, so it will be plus x tan 48, degrees will be equal to 50, tan 48 degrees. All correct, my professors?
Yes.
So just like we did in the other one, come and factor out your x. If you factor out x, you are going to get tan 30 here, 30 degrees, then plus what? Tan, 48 what degrees. And that should be equal to what? Your 50, tan 48 degrees. All correct?
Yes.
Okay. My professors, is everyone following?
Yes.
sir.
Yes,
Okay,
please.
wonderful. All right. So now we move on to, Prof. Genius.
So please, let's say this was given in an exam and somebody wanted to finish really fast. So he uses sign rule. Will he be still giving the full mark?
Okay, all right. Okay, so how are you going to apply so that the rest will know? I know what you are talking about. How are you going to apply the sign rule to get your age?
So there are 3 triangles. There's one that has the 30 and that's triangle ADC. Before the other 2 triangles you have drawn here, the DBA and the DBC.
So you find this angle.
You find for the angle in ADC.
So that's what this angle.
Yes, sir.
Okay, so How are you going to find that angle?
Sir, please, the triangles are equal to the total interior angle of triangles are equal to 180
Yeah,
degrees.
so this will give you your, okay, add these two, subtract it from 180. So that will give you the size of this angle.
So say then the sign rule states that except is the angle the I don't know how to put it. Except is
Okay,
the
do
sign
you
of
know something? Let me end with this, then I'll give you the opportunity to continue. Is that okay?
yes, sir.
Okay, so organize your thoughts well so that when I call you, you'll be able to flow. Is that okay?
Yes, sir.
All right, thanks. Okay, so now let's go. Okay, so we are going to get, if you proceed, okay, remember this is 50. So I need to write, okay, divide through by what I have here. So let me, I hope I created, yes, I did. So it will give us x is equal to, okay, what do we have there? We have 50 tan 48 degrees. So 50, okay, tan 48, okay, degrees all over, okay, tan, okay, which angle was it? 30 then, okay, so 30 degrees, okay, plus tan 48 degrees. Okay, so let me extend this to cover. Okay, so the rest becomes calculator work. Okay, so whilst you are giving me working for the calculator answer, okay, Prof. Genius, you can come in.
Yes, so please it states that the sine of the angle should be divided by the the angle facing it.
So
If
what will you write? Just write, give me that.
so, it will be
Sine. Sine. What are you using the sine rule to do? If I should ask you first, what are you using the sine rule to do? Oops.
please, it will be shorter if you are using it to solve for it.
No, I said,
Because
what will you use the sine rule to do here before? Because you have to find one of the sides before you can make use of the appropriate ratio.
please, you already know 50.
So you know this.
Yes. So when you find for the angle D, the sine rule, you use it to find for one other side.
No, that's what I'm saying. So you have to find one of the sides here before you can find H. You have to find either this side or this side. So that was what I was saying. I said, I understand. You have to find either this side or this side.
Yes,
okay, so without knowing this side, you cannot come and use this triangle. Without knowing this side, you cannot use this triangle. Or can use the appropriate trig ratio. It's allowed. There's nothing wrong with that. Is that okay?
Yes, sir.
All right. So on that note, okay, so that takes us, okay, to, so I need my final answer here.
32.8980.
898 was 0. Okay. And we are dealing with, what was it measured in meters? Okay, so 4 dp, is that not it? Okay, but remember, this is not your final answer. I hope you know that. Okay, so you are now going to find the height of the pole. So I'll write, therefore, okay, pole height. Okay, quickly, let me take a minute or two. Will be equal to, so that's the one that you presented by H. And that will be equal to, you said it will be, per what you have there, that will give us what? S tan 30, is that not it? So you get your X, okay, tan, okay, 30 degrees. So that will be equal to, what is your X? Your 32, okay, hey.
0.89.
Okay, so point what? 899, oh sorry, 98, or you can even ignore the 0 if you like, okay, because then what times what? Tan, okay, 30 degrees. Whatever your calculator gives you, you write it there. So far. And your calculator will give you a whole lot. You approximate to 4 dp. Is there any required approximation here? There is no required. So you end with the 4 dp, then you attach your units. Is that clear? Don't forget your unit. Is my point well made? Okay, so that will be it for, so unfortunately, we couldn't have our our, what do you call it, class assignment. So it will be given to you as a take-home assignment. Okay, please don't leave yet. Let me sign out. Okay, so thank you very much for making the class very interactive, for your time. Okay, and all that you lost to make the class very, very interesting and make it a success. May the good Lord continue to bless us. And once again, don't forget to subscribe, share, and like. Okay, bye-bye.